So taking up where we left off, we're going to review the interpretation of slopes of lines, and I'm going to use a product called Desmos to demonstrate. So I'm going to open up a web browser and go to desmos.com. And then when you get here, you say click on the graphing calculator and it opens a graphing app. You can also download the free app onto your phone, so you'll have a graphing calculator wherever you are. So on Desmos, you can use it to graph things like y equals 3x minus 2 and see how the line goes. And notice the gray dots. So if you touch the line and touch another line that's crossing it, Desmos will tell you the intercept coordinates of that point. So you can see we have 0, -2 is the y-intercept, and then about 2/3, 0 is the x-intercept. So you can use Desmos for drawing graphs, and then sometimes I'll ask you to reproduce the graphs on your paper to make sure that you can interpret the graph. But feel free to use this tool. It's a great tool for being able to visualize what we're learning about. So I want to show you some different examples. Each little number over on the left, there's a tiny number 1 on this box, and then if I click the next box down, it's number 2, number 3. You can put multiple graphs on the same grid. So I want to start off with y equals 0 and notice that that is the horizontal line that's the same as the x-axis. So a slope of 0 is a number. It's not no slope, and it's not the slope does not exist. It's a slope that is the number 0. Okay, then let's look at what does the slope look like if it's, y equals x. So that's a slope of 1. We don't see a multiplier of 1 if there is one, because we don't write that. We understand that it's there. It's one of the invisible ones of algebra. So y equals x has a slope of 1, so you can see that's a diagonal line. So it's actually pretty steep in terms of if you were going to hike up that hill. That's a pretty steep hill. So now let's look at what if I do y equals 1/2 x. Oh, that's not as steep. It's half as steep. You go up 1/2, up 1/2, up 1/2. So if I was talking about how something was changing, the green line, it's changing faster than the purple line. It's increasing more quickly. As x increases, y increases more. So then you can see if we continue going smaller, y equals 1/4 x is an even less steep line. So this is increasing more slowly even. Okay, so then let's look at what if we do y equals 2x, and you can see that that's steeper than y equals x, and you can get steeper and steeper. If we say y equals 4x, that's very steep. So as the numbers get bigger and bigger, the line gets steeper and steeper, and eventually you get to a vertical line, which you actually can't get. We can get Desmos to draw it by saying x equals 0, but you can't write it in the form y equals mx plus b because this is the line where the slope does not exist. There isn't a number that you can say that the slope is. Okay, then let's talk about lines with a negative slope. If we have y equals -x, now we're talking about something that's decreasing. And it's decreasing pretty quickly. That's a pretty steep downhill trend that we're seeing. But if we have y equals -1/2 x, that's not as steep downhill. So it's actually a larger number because -1/2 is larger than -1, so it can get confusing when you're talking about negative slopes. So let's look at y equals -1/4 x and see that that's even less steep. But then if we look at y equals -2x, steeper, and y equals negative 4x, even steeper. So I want to make sure you have a sense of, if the slope number is this, what does the line look like? And what is that telling me about the line? We're going to talk a lot about slope in calculus, so I want to make sure you have a good idea of what slope is telling us about. And parallel and perpendicular lines really don't come up in our practical applications, but they are in the textbook if you want to glance at that and review. So the second form of an equation of a line is the most useful one in calculus. It's called the point-slope form. It says if I know one point that's on the line and I know the slope, then I can write y minus y1 equals m times, in parentheses, x times x1. And this form doesn't tend to get focused on nearly as much in algebra, but it's actually the most useful one in calculus because we're going to know the slope from our calculus work, and then we're going to know a point on the line because somebody has to ask us, at what point are you interested? And this is going to be the most useful form of the equation of a line. You can leave it like this, or if you'd rather do the algebra to convert it to the y equals mx plus b form, you can do that. It just takes a little extra work. So here is the formal point slope form. A line has a slope m and it goes through a known point. Then you can write y minus the y coordinate I know equals m times, open a parenthesis, x minus the x coordinate I know. So let's do a little practice. Find the equation of the line through the point 5, 4 and negative 10, negative 2 in point slope form. So first we need the slope. So we're going to say the second y coordinate minus the first y coordinate over the second x coordinate minus the first x coordinate. So I'm going to have negative 6 over negative 15. We never leave a negative over negative, and we always reduce fractions. So this is going to be 2/5 for our slope. Well, now we can just go right to the point slope form. You don't have to solve for the b. If that's the only way you know how to do it, you're going to have a hard time doing this step that says write it in point slope form. So I really want you to practice that. So I'll have y minus. Now I can use either one of the points. So I'm going to pick the one that doesn't have negatives because that looks easier to me. So I'll have y minus the 4 equals m the slope of 2/5 times x minus the 5. And this is the answer in point slope form. Well, now we can convert it to slope intercept form by solving for isolating the y. So I'm going to distribute the 2/5 and have y minus 4 equals 2/5 x minus 2. And then I'm going to add 4 to both sides and get y equals 2/5 x plus 2. So this is the slope intercept form. Okay, then there's a third form that we will be seeing. It's called the general form, because this particular form, if the a and the b both divide evenly into the c, this is a really easy way to draw the graph of the line. So in this example, the a is 4, the b is 3, and the c is 24. So the a and the b both divide evenly into c. And so what that means is we can find the x-intercept easily by setting y equal to 0. So when y is 0, I actually put my finger over the 3y part, because if y is 0, 3y is 0. And then I can just see that the x must be 6. If you need to do a little bit more visible work, that's fine. I'd encourage you to get quick at this just because it will save you a lot of time. So then when x is 0, I would cover up the 4x, because if x is 0, 4x is 0. And I can see that the y then will be 8. So I know that the points 6, 0, and 0, 8 are on my line, and I only need 2 points to accurately graph a line. So you can see that this would be a really quick way of graphing lines, but it only works if a and b divide evenly into c. Otherwise, you need to go back to this slope intercept form. Okay, so here's an example that doesn't work so well. 6 doesn't divide evenly into 16. 9 doesn't divide evenly into 16. So you would need to subtract 6x from both sides and get negative 9y equals negative 6x plus 16. And then divide both sides by negative 9. And here's where the algebra comes, where we have y equals 6 over 9 reduces to 2/3 x minus 16/9. So this would be a pain in the neck to graph. You'd need to subdivide your graph into ninths and have each box be 1/9 in order to make a good graph. Okay, then we're going to review section 6.1 is a system of linear equations. So a system of equations is more than one equation and they're linked by common variables. So if x is the number of sweaters and y is the number of coats, then x and y are representing the same thing in both of the equations. That's called a system of equations. So a solution to the system is a solution that makes both equations true. In this case, the point 2, 1 makes both equations true, and I'm going to show you how I found that. But let's try it. If I put 2 in for x and 1 in for y, yep, I get 7 in the first equation. And if I put 2 in for x in the second equation and 1 in for y, I get 8. So the point 2, 1 is called a solution to the system. The single point, one object, a dot on a graph, 2, 1, is the solution to this system. Well, one way of finding the solution is the graphing method. We graph both of the lines and look for the point of intersection. So let's see, the blue one has a y-intercept of 2. So we know we're going to have plus 2, and the slope is down 1 over 2, down 1 over 2. So negative 1/2 x plus 2, that's the blue line's equation. And then the red line's equation, let's see, that one's going to be a little harder, but we can see that 2, 1 is the solution. And then from that solution point, the red line has a slope of up 1, 2, 3, 4, 5 over 3. So it has a slope of 5/3 x. And we can figure out what that b must be by putting in 1 for the y, 2/3 for the x, and we'll solve for the b. And you're welcome to use a calculator. In fact, I really encourage you to learn how to use this button on your calculator to work with fractions. So you'd get b is negative 7/3, and you'd have y equals 5/3 x minus 7/3. So you graph those two equations on the same grid. The line with the positive slope is our first line. If we multiplied both sides by 2, we'd be able to see that it's the same line we started with, and the line with the negative slope is the second line. Okay, so this point 2, 1, this is the point we found was the solution by graphing the two lines and looking for their intersection point. We can also solve this system algebraically using one of these two methods, either substitution or elimination. And it doesn't matter to me which one you use. Most students have a distinct preference. So let me come back up to the equations of the lines. So we had 5x minus 3y equals 7, and 2x plus 4y equals 8. So I'm going to bring that down here to where we have the space to do the work, and write 5x minus 3y equals 7, and 2x plus 4y equals 8. Okay, so the substitution method says solve one of the equations for one of the variables. So it doesn't matter which equation, and it doesn't matter which variable. You're free to choose. So I usually kind of look at it and go, well, the second equation, those are all nice even numbers, and so it looks to me like it would be easier to solve the second equation, probably for y, because I know I'd be dividing by x at the end. So I'd say solve the second one for y, where this is the second one. So I'd have 2x plus 4y equals 8. Solving for y means get y all by itself. So I'll subtract the 2x from both sides. And then divide both sides by 4. And have y equals negative 1/2 x plus 2. Now you substitute, that's the name of the method. You substitute this y into the other equation, so equation 1. So we're going to have 5x minus 3 times y is negative 1/2 x plus 2, and that's going to equal 7. So now you can see I only have an x variable left, so I'm going to be able to solve for the x. So I'm going to distribute the negative 3 and get 5x plus 3/2 x minus 6 equals 7. So I need to add the 5 and the 3/2 x together. So if it helps, you might want to remember how to put things over common denominators. So I have 10/2 x plus 3/2 x, or 13/2 x. Add 6 to both sides. And then I'm going to divide by 13/2. So remember that dividing by a fraction is the same thing as multiplying by the reciprocal. So I get that x equals 2. So that's the first part of my solution. Then I have a formula right here that says if I know what x is, I can find y. So y is going to equal negative 1/2 times this x plus 2, and that's going to be 1. So then I write my answer as 2, 1. So that's the substitution method. So then let's look at the elimination method, where I have 5x minus 3y equals 7 and 2x plus 4y equals 8. So make sure everything's lined up in this method, that you have the x's above x's and the y's above y's and the numbers together on one side of the equals. So what you want to do is have the same number for a coefficient on one of the letters, but the opposite value. So I have 5x in the first equation and 2x in the second equation. So do you see how if I multiply the first equation by negative 2 and the second equation by 5, now I'm going to have negative 10x in the top equation and 10x in the bottom equation, so the x's will eliminate. So that's why that's the name of this method. So I'm going to distribute the negative 2 and have negative 10x plus 6y equals negative 14. Distribute the 5. 10x plus 20y equals 40. So I have 26y equals 26. So y equals 1, just like we knew it should. And then you can use either of the two equations you started with to find the x. So I'm going to use the second one because it just looks a little easier to me. So I'd have 2 times x plus 4 times the y I just found equals 8. Subtract 4 from both sides. And sure enough, I find that x equals 2. So make sure and write your answer as an ordered pair. So finding the solution to a system of linear equations is the same thing as finding the intersection point of two lines. And I put a red box around this because it's really important. Finding the solution to any system of equations is the same thing as finding the intersection points of the graphs of the two equations. So I'm going to go ahead and pause here and make another short video.